All right, so to begin with, there are a lot of skills on this test, and I'm going to start with some of the easy ones. So on that note paper I had you take out, I want you to show me, if you know, where 3 pi over 4 is. Always make a circle and a big plus through it. Show me where 3 pi over 4 is. And then, if you can, draw me a reference triangle that goes with it. I'm going to pause for a second here. All right, so you should have said that 3/4 pi really comes down to 3 sets of 1/4 pi. You get what I'm saying there? It really comes down to 1/4 pies. 1/4 pies are that big. Because the whole pie goes to here, right? So 1/4 would be here, 2/4 would be here, 3/4 would be there, and that's the one I want. So there's my answer. 3/4 pi, just like that. 3/4 pi. Raise your hand if you had that in the right spot. Okay, good. And then to make the triangle, all you got to do is drop to the x-axis. Doink. And over. And there we go. Okay. And now, what are the angles? Well, this angle right here, it's important that you get that that is 1/4 of pi. It's right there. It's pi over 4. 1/4 pi. Why? Because this is 3/4 of pi, and that's the part that's left. Right. So that's 1/4 of a pi. And now, I would also want you to be able to be fluent enough in this to say, oh, that's 45 degrees. Why? Because you should just memorize that pi over 4 is 45 degrees. So why? Why couldn't you just do it in radians? Well, you can. But then you won't recognize that it's a 45, 45, 90 triangle unless you memorized it as the pi over 4, and pi over 2 triangle. Because really it is, but the 45, 45, 90 is what you're probably going to be thinking of, not a pi over 4, pi over 4, pi over 2 triangle. Right, so now you'll also know that the angles would be, or sides would be 1, 1, and 2. That's the ratio. You don't have to have all that later. All I would have had to have there was pi sticks. The triangle, it's got pi over 4 as the reference point. Okay? Let me give you another one that's a little trickier that might make it all the way up to like R3 level. Let's make it negative, which just means you go the opposite direction. Go like down like this. Let's make it negative, and let's make it huge. Negative like 9/6 pi. Draw me a reference triangle for negative 9/6 pi. Yes, we can do some. Show me where the reference angle and the reference triangle would be. My advice is making that into just figure out where 1/6 pi is. In this case, the negative 1/6 pi. And that would just want to be 1/6 pi's are like 30-degree wedges. Okay, so 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6 is a great way to check yourself. 6, 6 pi. Yeah, that makes sense. Those will cancel, and this is pi. 7, 6, 8, 6, 9, 6 is right there, isn't it? Isn't it? This one? All right, because it was 1, 2, 3, 4, 5, 6, 7, 8, 9, 6 right there. So, final answer is it's like this. And do you get that you cannot draw a triangle for that one? When it's on one of the axes, you can't make a triangle for it. Okay, so there is no triangle. It's a trick question. There is no reference triangle. Stay with me. All right. So this is another spot. If it was there, I'll just make a scene. If it was right here, at 2 pi, for instance, or at 0 degrees, you can't make a triangle for that. Okay. Any other place besides these 4 spots are the ones you can't have. You can't have one here. No triangle if it's there. If the terminal angle is there, no triangle for that. You know, some people think you should just go like this. No, you can't do that. You have to drop to the x-axis straight down or straight up. If it was right here, again, can't make a triangle for that guy. And last, I'll do another green one here. Can't make a triangle for that. all you do is you drop it down and you label what it is, which might have been like negative pi over 2 or something. Or if I had said it another way, it might have been positive 3 pi over 2. So that's all you do is label it like that. All right, so let's try another topic we need you to be good at. 30, 60, 90, 45, 45, 90. Draw them both. So what their sides would be. Okay, did you have 1 across from the 30, 2 and the square root of 3? And on the other one, 1 and what? Square root of 2. Good. All right, now let's use those triangles. Let's see how you have that in a real problem. Let's say this is 30 degrees, but this isn't a nice one like it's supposed to be. Let's say it's a 5. Still pretty easy to get the other two sides. Give it a shot. Hoping you're saying to yourself, it's easy. It's twice as big, so that's a 10. And this would be square root of 3, but it's bigger than normal, so it's how many times bigger? 5 times bigger. 5 root of 3. Raise your hand if you had those right. Okay, good. Now, how about if I make it trickier, though? And the spot that's supposed to be square root of 3, it's not square root of 3. So this is 30, this is 60, this is 90, and that's 11. Then how big is, I'm going to call that A. How big is A? There are several ways you could figure this out. Would you please use one of them and figure it out? If I were you, I'd make a helper triangle off to the side, but it's got the same dimensions, like same size. You go off to the side and make another one just like this. Except this one, my side ratio is a bit more. What's going on? Nope. Because it's a 30, 60, 90, it's something you can do without a calc. And this whole test, there's no calc. So we will only use triangles where you can do that, you know, like 30, 60, 90, 45, 45. All right, so the helper triangle. It's got 30, 60, 90 also, and it's got 1, 2, and a square root of 3. So here's a way to do it. Like the ACT questions. 11 is 2 root 3 as A is 2, 1. 11 is 2 root 3 as A is 2, 1. Cross multiply, solve it. See, I cut the whole trig right out of it. I didn't even use sine, cosine. Do you like that way? Right. Now, some kids don't. Some kids teachers, I'm recording this video for everybody, some kids teachers haven't even shown them that. So I'm going to go show you the other way, which is totally fine too. You could say that I want to use sine because I want to use, wait, not sine. I want to use opposite and adjacent, so that's tangent. So, opposite and adjacent means I must use tangent. Tangent of 30 is opposite, okay, over adjacent 11. If I asked you to do this, the problem would be some kids would be stumped on what's tangent of 30. They shouldn't be, because that's where you'd use this triangle. What's tangent of 30? From the 30th perspective. Tangent is opposite adjacent. 1 over root 3. So this part right here, 1 over root 3 is equal to A over 11. You see I've still got the same little proportion where I got to cross multiply and solve it. It's just I skipped the whole sine, cosine, tangent. But you can do that. You're still going to have one of these to solve. That does that, that does that. It's going to be 11 A root 3, divide by 11, or divide by root 3 on both sides. And it'd be 11 over root 3 is equal to A. All right, I want to give you one more like that and see if you can handle it. Let's make it a 45, 45, 90, except I'll make it a little more obscure. And let's make this side 17. And I want to know M as in monster. I can only say that on the test you will have to show your work. You're certainly welcome to do stuff in your head, but if you got an answer, it needs to be backed up by, I got this from this minus that, or whatever. Okay, so you got to say where the number comes from. I understand what you're saying. There are ways to do these in your head, but you have to have some work to back it up on. All right, so this one's a 45, 45. I know that because I have memorized that pi over 4 is 45. You didn't know that. You had pi over 4, and you were like, oh, I can't remember which one that is. Just multiply it by 180 over pi, pi over 180. Hopefully, if you put it even in there wrong, you'll be like, wait a minute, I can't cancel the pi's that way. So you would back up and do it this way. And you cancel, and then you just got to have the task of reducing 180 over 4, which is a little bit of a pain. 180 goes in there, or, sorry, 2 goes in here 90, 2 goes in here twice, do it again, 2 goes in here once, 2 goes in here 45, and I got it down to 45. So I'm just saying, you don't have to memorize those, but look at how much work that would have saved you. So now, I make my helper triangle. I really do recommend it. You make the same size, same orientation as the other one, and then you go, this is a 45, 45, so 1 1 squared 2, and then I can do that whole, like, this is to this, that is to that. I'm going to do it that way. 17 is to root 2 as m is to 1. Just a shortcut here. F over 1 is not the same as m. So m is equal to 17 root 2. Done. If you want to do it the sine, cosine, tangent way, totally fine. I'm going to go, I'm going to use, let's see, from this angle's perspective, I'm going to use the opposite and the hypotenuse, and that would be sine. So sine of 45 is opposite for hypotenuse 15. And then I just got to figure out what sine of 45 is, but I know that by looking at the helper triangle. You still need the helper triangle. And the helper triangle tells me on sine of 45, I'm going to use this 45, opposite over hypotenuse is that over that. So it would be 1 over root 2 equals m over 17. Cross multiply solve. You'll end up with the same deal, that it's 17 equals m root 2, 17 over root 2. There's 2 ways to do it. You pick. Choose those choices. All right, next one. Let's say I had a reference angle of negative 9 12 pi. Figure out where that. Right away, I'd probably simplify that. That's 9 12 3 goes 2. So 3 goes in here 3 times, 3 goes in here 4 times. Negative 3 pi over 4. Negative 1/4 of a pi be right there. 3/4. Right like that. Right? Big. And then to make a triangle for it, you just go. Alright. Moving on. Different kind of problem. Let's talk about changing into degrees. Let's go with 2 pi over 3. I don't have that one memorized. You might know what 1 pi over 3 is, and then just double it, but tell me what this is in degrees. Pi over 3 is a kind of good one to know. Pi over 3, what's that one? 60. So what's 2 pi over 3? Just double this one. This one's 60. 2 pi over 3s would be twice that much, so it would be 120. That's a great shortcut, because you have something memorized. What if you're the kid who doesn't have it memorized? Then you're going to have to do it the long way. you're going to have to multiply it by pi over 180 or 180 over pi. Make sure you put it on the bottom so it'll cancel. Cancel, cancel. And if you're really not smart about this, you will multiply 2 times 80 is 180 is 360 over 3, and then you'll be stuck trying to reduce 3. It'd be much smarter to go, 3 goes in here how many times? Once. 3 goes in there 60 times, and then 2 times 60. Alright, questions on that one? Yes. Yes, so if this question originally was like this, how would you do it if you memorized it? What I would ask you to do is say, I know that this is 2 pi over 3, and that's 60. So then that's 1. You know what I'm saying? Just something like that. If you just have an answer, it looks like you looked over the other kid's paper and thought, you go right there. All right, next one. Sine of pi over 4. First thought on that one is, I don't really like pi over 4. I'd rather have to get, what would that be? 45. So can you tell you're in a 45, 45, 90 triangle now? The reason I like that is because some people are saying just know the radians. You really got to know both. Unless you want to memorize the 45, 45, 90 triangle as pi over 4, and pi over 2 triangle, which sounds really, really dumb. Anyway. So then I'm going to go sine 45. That's just a straight swap. Those are exactly the same thing, right? So then what's sine of 45? Make my little triangle. 45, 45, 90, 1, 1 square root of 2. Sine of that is opposite over hypotenuse, which would be 1 over root 2. Raise your hand if you had that one right. Okay, good. Then let's move to the little more complicated kind. So the sine of pi over 4, what's cosecant of pi? Well, first thing I'd do is make sure you know which kind of triangle you're in. So is it a 30, 60, 90 or 45, 45? It's 45. Because this one's really 3. So then I'd know, oh, I'm in a 45, 45 triangle. So that's like this. And then I would say cosecant. I don't even know what cosecant is. Unless you happen to remember Cho Sha Kao. Do you have any clue what I'm talking about? It's the comparable thing to SOHCAHTOA, except it tells you cosecant, secant, and cotangent. No, you don't need to know that, but it's kind of fun. So if somebody hits you with the SOHCAHTOA, you can say Cho Sha Kao, and that's like the next step. All right, because it's hypotenuse over opposite. Notice that's compared to SOHCAHTOA, all of these two are reversed. O and A are now A and O. AH is now HA, and you know what I'm saying? And OH is now HO. All right, anyway, I personally would just say, I don't want to do cosecant. I want to do the function that goes with it, the sister function to it. And here's the list of the functions that you better know. Sine, cosine, tangent go with the sister function of cosecant, and cosine is secant, and tangent gives you cotangent. And they're all a flippin' sister because you flip the answer over to get that. So if the sine of theta is 1/2, then this one, the cosecant of theta, will be 2 over 1. They flip. Okay, so moral of the story is, I wouldn't do cosecant. I would just say, I'm not doing it. I'm going to do sine. But then if you just change the problem to sine, you'll get it wrong. You got to remember that it's the flip of that. I'm going to put 1 over that. What I did there? I'm reminding myself to flip it at the end by saying 1 over that. And then sine of 45, I can go down to this triangle here, the helper triangle, 1, 1, square root of 2. And you're going to go sine of that is opposite over hypotenuse, 1 over 2. Instead of that, I'm going to say 1 over root 2, and that'll remind me to flip it. 1 over something does that. It's the inverse. So now it's root 2 over 1, root 2. Raise your hand if you got that one right. Good. Okay, next one. Let's do another weird one. Cotangent of 2 pi over 6. Good, no. It's not good. But it's got a curve in it, so give it a shot. Might want a helper triangle. So first off, get rid of this nonsense of 2 pi over 6 and just make it what? Pi over 3. And what's that the same as? So cotangent is 60. Those are all just equal swaps. But I can't just swap out cotangent and tangent because those are different. So if I'm going to change the tangent of 60, which would be nicer, I got to not just change it. I got to say 1 over tangent. See what I did there? Cotangent and tangent, not the same thing. Then, what's tangent 60? Still got to have a helper triangle. 60. Weird. I'm used to doing 30. 60 is 1, 2, 3. 60's tangent opposite over adjacent is that over that, and so it would be 1 over root 3 over 1, which would be flip that 1 over 3. Raise your hand if you got it right. Good. Lunchtime. All right, so we're back from lunch, and I want to do a little bit of rapid fire stuff you should know. Do you know what that is? 45. How about if I said that? 90. How about that? All right. How about if I said I was in a triangle and one of them is pi over 6? What would that be? 30. So what triangle must it be? 30, 60, 90. All right, good. Now, back to what do you have to know how to do? One of the problems on that worksheet that you still have to finish has got like one side and one angle. Let's say it's 8 here and it's like 23 degrees there. How do you do that kind? Well, there's 2 other sides. And if I figure out one of them, let's say I figure out that one. Once I know 2 of the sides, couldn't I just use Pythagorean theorem to find the 3rd side? Yeah, I could. So I just need to find one of my sides, really. But I could find both of them with this next method I'm about to show you. Would you please write this one down on your notes? Draw this little picture. And then if you're going to figure out A, try to figure out which one you should use. Sine, cosine, or tangent. And then set it up. And I don't expect you to know what sine, cosine, or tangent of 23 degrees is. But that's how you start. All right, so which is it? Well, I've got opposite and I've got hypotenuse. That means sine. Sine of 23 degrees would be opposite 8 over hypotenuse A. And now, is A alone yet? No. So I got to multiply both sides by A. So that means A times sine 23. Notice I didn't try to figure out sine 23 because it's kind of hopeless. Equals 8. And now to get the A alone, I'm going to now put the sine of 23 underneath the other side. A equals 8 over sine 23. And now I'm done. I got the A alone. It's okay to leave something like sine of 23 in your answer if it's 23 degrees. The only problem would be is if it was 30 or 60 or 45. Because then you could go make a helper triangle and actually figure it out. Okay, but if you get one that's weird like this, that's not 30, 60, or 45, then you can leave it like that. So you got a couple like that in your worksheet. Don't be afraid to just leave the answer with a sine of 23, for example. All right, now that was me helping. Let's see if you can do this next one all by yourself. Pi over 4 for this one. May not look like I've drawn it that way, but that's what I want it to be. If that's pi over 4, and this is 9, tell me what r is. That's pi over 4. first thought, you should have known that was 45. Degrees. Next thought, you should be thinking sine, cosine, 2. Let's see. First one we have adjacent and hypotenuse. Adjacent and hypotenuse is that one. Cosine of 45 is adjacent over hypotenuse, which is r over 9, and I'm almost done, except here's the thing. You can figure out what cosine of 45 is, can't you? You know what I'm saying? You can't just leave cosine of 45 in your answer, because that's one of the ones we know. So, a helper triangle for you. 45, 45, 90, 1, 1, square root of 2. Cosine of 45, hold on, raise your hand. Cosine of 45, cosine is adjacent over hypotenuse, 1 over root 2. 1 over root 2 equals r over 9, and now it's a cross multiply kind of question. And you'd end up with, let's see, 9 equals r root 2, so it would be, and I divide by root 2, so it's r equals 9 over root 2. Okay, any questions about that one? All right, another kind. I'm more interested in making sure we've covered everything you need to know for the test than I am of finishing that worksheet. So you need to finish the worksheet, but I want to make sure I cover everything that you need to know. So here's another kind of question I want to make sure you're good at. Remember the sister functions? Cosecant of, let's do one we know, pi over 6. There isn't a triangle involved, you're probably doing something wrong. Lunch has wiped part of my brain clean, so I'm wondering, did we talk about arc length problems or not? Okay, well, we better talk more about that because that's important. Okay, so let me finish this one first. First off, I hope you know pi over 6 is 30. If you haven't got it memorized, you'd have to do it some other way, but I'd know it was 30. If you didn't, you'd go pi over 6 times 180 over pi, do some canceling. 6 goes in there once, 6 goes in there 30 times. It's 30 degrees. Okay. So I can rewrite this as cosecant of 30. At least I'm a little bit better off than I was. Because now I know I'm in a 30, 60, 90 triangle. Next thing, I don't like cosecant. So instead I'm going to use the sister function, which is what? Sine. So I can't just swap out sine and cosecant. They're not the same thing. So I go 1 over sine of 30. I happen to have memorized sine of 30 because it comes up so much. What is it? Anybody know it? Sine of 30? Sine of 30 degrees is a half. Just like you memorize a lot of other things, I'd memorize that one just because it comes up a lot. Save you time. Now, if you aren't good at that, then go off to the side. 30, 60, 90. I can do sine of 30. I can do 30s, 60s, and 45s. So sine of this, 1, 2, 3. Sine is opposite over hypotenuse. Hypotenuse, 1 over 2. Right here is 1/2. So 1 over 1/2. And the 1 over is a reminder I got to flip the answer because remember I'm doing the sister function to figure it out. The final answer would be 2. Raise your hand if you have that. Okay, good. All right. Do you want more practice on that kind, or do you feel good about that kind? So mostly people saying they're feeling good about that. Let's move on to this formula. S equals theta r. Terrible formula. I don't like it in a couple ways. It works, though, but I don't like it for 2 reasons. First of all, it's an arc length formula. Do you see any A for arc in this? No. And that confuses people because they're like, where the heck do I put the arc? Well, it's the S. S is where the arc is. Okay? But why they pick S? Why can't they pick A for arc? Okay, I'll give you the A's area, but what's S then? So it could potentially be confusing if you said A, but if it's S, nobody has any clue what that is. Semicircle? All right. That's a stretch. Anyway, point is, as long as you know that's where the arc goes, that's, just to be clear, we're talking about here is like a little distance like this along a circle, that's an arc. Okay, so that's a length. This is degrees or radians, but you can't use degrees until you change them into radians. That's the other thing I don't like about this formula, is you have to use radians in it. So you might, by mistake, think, oh, I'll just slap in this 120 degrees here, and it'll get it wrong, because you have to change to radians to make this work. And then the other thing I don't like about it is there's radians in the formula, and there's also an R, which doesn't stand for radians. It stands for radius. Okay, so there's a myriad of things that are wrong with this, but try to overcome. Here's the formula. Use it to figure this out for me. You're sitting in the middle of a lake with your grandpa in the boat. He says, you know, I reckon I could probably divide this up into a circle. And I could say that I probably own a 30 degree, if you go at a 30-degree angle here, I'd own all that property. You'd own all this property along the lake. Do you need to know any more? How far are you from the shore? If you're right in the middle of the lake, that'll be the radius. And the radius of this lake, it's a 1 mile radius lake. 1 mile. Okay, so how much land does Grandpa own? Figure it out. He's old. All old people are rednecks. Do they have the equivalent of rednecks in Venezuela? What are they called there? Maracuchos? Beach bum kind of people? Okay. All right. Good to know. Gotta know what that thing is. What's it called again? Maracuchos. All right. Cool. All right. They like park cars in their lawn. Let's see. Bring a couch to the beach and sit there. Awesome. All right. I'm sure there's some fun things about being a redneck here too. Your iguana has more teeth than your girlfriend. All right. Let's go to S equals theta r. I don't know S, so I put S. Theta, I know, except I put in 30, I get it wrong, because they can't use degrees. So I changed that over, and I happen to have that memorized, pi over 6. See how handy it is to know those? And then the last thing is the radius. The radius is 1. So then I go S equals pi over 6 over 1, and you might feel like you got it wrong, because that looks like some kind of a degree. It's just 3.14 divided by 6. You get how that's about a half? Because 3 over 6 is about a half, right? So it's a little more than half, and if we're talking miles here, that means Grandpa owns about a half a mile of shoreline. He's probably pretty wealthy then, because that's expensive. All right. I do know somebody that owns 4 square miles up north. Think about that. Yep. 2 miles on each side of their property. Kind of squarish. Pretty. It's a lot of land. No, it's actually just like hunting type land. It's not farming. Now, if it was farmland, holy crap. This farmland has gone up so much in value since you were born. When you were born, farmland was about $3,000 an acre. It's now selling for $11,000. That means a typical farmer, just in land, if they own their own land, is well over $1 million. There's a lot of like 10 million because their land has gone up in value so much. That's part of the problem. Yep. If they sell off the land, then they're not a farmer anymore, right? So. But they still own it, so it's theirs, so it counts towards their net worth. But it does get complicated when tax time comes along, because you know what Minnesota says? If you have more than $1 million, they charge you, like, so when Grandpa dies, gives the farm on to the next person, if it's more than $1 million, Minnesota wants 40% of the first 100,000 that goes over $1 million. And so bottom line is, yeah, it's okay. I can record this. It's true. Minnesota charges a lot of tax for if you go over $1 million. So if you're a farmer and you want to hand your property down to the next generation, it's really expensive. But people would argue that, well, if you know that's coming, then you should buy life insurance. The idea is you buy the life insurance so that when you die, you can take that life insurance money and pay off the taxes, so then your family can keep the farm. So anyway, there's ways around it, but it's still, you're right that it's not just like having 10 million in the bank, because you don't want to sell it, because otherwise you can't farm anymore. All right, well, let's try another arc length problem. I'll make it simpler for you. No story. Pi over 3, and this is 11. The arc itself is 11. Figure out the radius. Give it a shot. Angle's pi over 3. The arc's 11. So right away you should be going, oh, S equals theta r. That's the arc formula. S, I know S this time. It's 11. And I know theta this time. It's pi over 3. Notice I didn't really want to change that to 60 degrees because this formula won't work with degrees. And the radius is unknown, so I put r. And now I'm going to solve this. Now you could divide both sides by pi over 3, but I'm going to get rid of this by multiplying both sides by 3 over pi. Okay, so I'm going to times by 3 over pi, times by 3 over pi. That way, this will cancel this will cancel that, r's alone. R equals 3 times 11 is 33 over pi. And if you want to know exactly what that is, you'd have to take 33 divided by 3.14. Okay? Now, one thing that kids get confused about is sometimes the test will say, leave your answer as an exact number. And then people think, well, then this can't be right because I don't know what pi, I haven't put in what pi is. But it's actually exact. That's the exact answer. As soon as you change it to 3.14, now you've estimated it. Because 3.14 isn't exactly what pi is. So if you want an exact answer, leave it like that. If you want a number that's more friendly to understand, you do 3.14 for pi and get a decimal, but it's not exact anymore because pi isn't 3.14. It's close to it. Yes, sir. Those are the biggies, yes. Pi over 3, pi over 4, and pi over 6 come up a lot. But will they ask you other ones? Absolutely. They'll ask you what's 7 pi over 6, but then you'll have to know, oh, that's pretty much the same thing as, well, 1 pi over 6 7 times. Unless they can be reduced to that. Yes. Good question. There was a question on your homework that involved the law of sines, but I can promise you that law of sines is not required on the test. So the reason is there's a problem. Let me see if I can find it back here. Move this over. I know it's a triangle. I don't know if it's a lot. Oh, a triangle. There we go. There's the question that was in your homework that I used the law of sines to solve, except didn't have that blue line in there. It was like this, and I'm like, wait a minute, we've never learned anything about triangles that weren't 90-degree angle ones, right? I was thinking 30, 60, 90, but no, this isn't the right triangle right there, or right angle. So that doesn't work. But so I used the law of sines, which is a cool thing, but you don't have to know that yet. You're going to learn it and use it more in calc and stuff. But for right now, you aren't expected to know how to do that. You're expected to notice that, oh, if I put a line right there, you see how I got 45, 45, 90? Right here. And over here, you got a 30, 60, 90. And now you can do it with using that information. So you're expected to be able to handle 30, 60, 90s and 45, 45, 90s, which is really what you have. So don't worry about the law of sines. Thanks for asking. It's good that you knew that possibly could have been on the test, but it's, I can promise you. Yes, sir. All right. Good question. So let's say they gave you one where they said pi over 4 is the key spot. Okay, well, and I'd know 1/4 of a pi. That's like this. And I could draw the reference triangle for that, right? When they ask you what are the coordinates of this spot, do you get what they're really asking is what's x and what's y? And x is this distance, and y is this distance, right? So by asking you for the x and y coordinates, they're asking you really for what are those two sides of the triangle. And since I know that this is a 45-degree angle, then I know that this must be 1, 1 and the square root of 2. And therefore, this spot must be 1, 1. So when they're asking you for coordinates, they're really just asking you for this side and this side. Okay? So as long as you can get those sides, you'll be fine. Yes, sir. Read 36A. Get some kind of a picture? Or, okay, sine of... All right. My first thought on this one, as soon as you gave me sine of theta is root 2 over 2, is I want to draw a triangle for this. And I don't know how big this is, so I put a theta. And then I know that you just gave me the opposite and the hypotenuse, because I know that's what sine is. So you just gave me the opposite from this is root 2, and the hypotenuse of this is 2. All right. Now this is tricky, because you're probably thinking it's a 30, 60, 90, but if you think about it, that can't be a 30, 60, 90. What it could be is, what if this was square root of 2? Do you get how it could be a 45, 45, 90? So now, boom, I know this is 45 degrees. And once I know it's 45 degrees, it'll be easy. But what's the other thing they ask you about this? Just give the answer in degrees and radians? Okay, so if they want it, I know it's 45 degrees, and I also know that's pi over 4. Yep. Acute just means angle less than 90. So they don't want you to draw a triangle that's like hugely open, you know, like a triangle like this. That wouldn't work for you. They're just trying to remind you to keep your triangles to be right triangles, so that your angles in them will be acute, as in less than 90. Any other ones you want to ask about from the packet? I'll be glad to do anything else from there that you want. Yes. All right, hearing no more questions, I think I've worn you out. So this is the part where you go home, you finish the packet. You will have some on there that probably trip you up a little bit, and that's okay. Struggle with them a little bit, then look at the answers, try to figure it out. Oh wait, you know what? There's one more kind of problem I know is on there that I want to make sure you get. Let's say you have like a 6 here, and a theta here. No, let's go with this. A 6 here, and a 4 here, and this is a theta. Like that. Okay, there. What if they give you that info, and they say, what if they said, what's the sine of theta? That would be really easy. What would be the sine of theta? Sine of theta is opposite of hypotenuse, 4/5. Done. But what if they ask you for the cosine of theta? It seems like you can't do it, but can you figure out what this side is right here? Yes, you could. And you'd have to use Pythagorean theorem then. A squared plus B squared equals C squared. Can you get that that's question mark side must be 3? Remember the 3, 4, 5 triangle? So this side must be 3. Now that I know that, can you tell me cosine of theta? Cosine of theta would be adjacent to hypotenuse. That 3/5. Notice I didn't even have a 3 when I started the problem, so I couldn't have figured it out until I figured out what the third side was. That kind is important. All right, now I think I've covered it all. I encourage you to get your homework done and check it. Remember that tomorrow when you turn in your tests, or when you start your test, you need to turn in all of your homework to me at that point. There are like 5 worksheets there, including the review packet. And I'd say if I was picking, I can guarantee you the review packet is the most important thing because it covers everything. If you spaced on one of your days and didn't have that done, it's not going to hurt you near as much because the review packet covers everything you got to know. So make sure that's